Hello and welcome back to Gaffey's Grinds. My name is Mr. Gaffey, Leaving Cert chemistry teacher, trying to help you understand some Leaving Cert chemistry concepts a little bit better. I'm going to take the concepts, break them down, and give you some practice questions to do. A few quick reminders for using these videos. Don't forget to turn your phone off, put it in a different room unless you're using it to watch this video, and don't have other tabs open on your computer. Close them now. Again, the less chance of distraction that you have, the better you're going to learn in this video. The most important thing, as I always say, is that I'm going to give you practice questions and tasks to do. It's really, really important that you actually do the tasks. Otherwise, you're not going to learn as much. Really, really important to do the tasks. Okay, this video is video number 3 in our organic chemistry series. We are currently studying fuels. And just to start with today's lesson, we are going to do some recap questions. Okay, so what I'm going to get you to do, obviously, if you haven't watched video number 1 and number 2, then these are going to be difficult. You're not going to understand them. You're not going to be able to answer them. So it's really important that you go back and watch them in sequence, in order. So go and watch video number 1 and number 2. Assuming that you are with us on video number 3, I want to pause the video now and complete the questions in your practice copy. Okay, and you should only now be watching the video and hearing my voice if you have stopped the video and tried to do all of these questions. Okay, so very quickly, I'm going to stick up the answers here. I'm not going to go through them in detail because we really have done this in great detail already. Those are the answers. So just check your answers now and fix anything that you had incorrect. So this is just really serving us as a quick reminder of the stuff we know already. So pause the video, make any corrections you need to make. Good, so you should now be watching and listening again if you have made those corrections. Okay, in today's video, we are going to focus on our first homologous series of hydrocarbons. I'm using 2 words there that you should know what they mean because we did them in the last lesson. A homologous series. You should pause the video and try and say out loud what a homologous series is now. Okay, they are a family of compounds, a family of organic compounds with similar chemical properties that have the same functional group. They differ by a CH2 unit and they have a similar method of preparation. And we are talking about a homologous series of hydrocarbons. So what is a hydrocarbon? Say your answer now on 3. 1, 2, 3. I'm hoping you said a compound made of hydrogen and carbon only. Now the first homologous series we're going to look at is an aliphatic hydrocarbon. Again on 3, what is a aliphatic hydrocarbon? 1, 2, 3. Okay, and I'm hoping that you said aliphatic hydrocarbons are hydrocarbons with branched or unbranched chains of carbon atoms or in cyclic compounds, but they do not have a benzene ring. They are not aromatic. Only aromatic compounds contain a benzene ring. So they are hydrocarbons with no benzene ring. They can be straight, they can be branched, and they can be cyclical. Okay, so our first family that we are going to look at in detail today is called the alkanes. So we are going to be looking at alkanes. Okay, so we spell alkanes like this, A-L-K-N-E-S, alkanes. So the first thing we know is that they are homologous series. I told you that already. They are a homologous series. The second thing that we know is that they are hydrocarbons. They are all hydrocarbons. And the third thing that we know is that they are aliphatic. Okay, aliphatic. Now, alkanes are a homologous series, which we know means they all share the same functional group. Now, what is the functional group of the alkanes? Well, we represent it like this. We show it as a C bond, single bond to C. What does this mean? It means that all the carbons are singly bonded. So they are only ever singly bonded, are singly bonded. Now carbon, you should know how many bonds carbon can form. If you don't know, you should look in your periodic table and find out how many valence electrons it has. And then you would know how many bonds it can form. So go to your periodic table now, pause the video, go find the answer if you don't know already. And then once you find the answer, I want you to call out your number, call out your answer on 3. The question again was, how many bonds can carbon form on 3? 1, 2, 3. Okay, I'm hoping that you said 4. So all carbons are singly bonded to 4 atoms. That is the functional group of the alkanes. They are all C, single bond to C. All the carbon atoms are singly bonded, all single bonds. Now, just as an aside, what would not be an example of an alkane then? Well, if we had a compound, so what would be an example? Sorry, I'll start with an example. So an example, e.g., would be something like this. 2 C's, and each one is singly bonded. So see, this carbon here has 4 bonds. It has this one to the other carbon, and then it has 3 hydrogens attached. So that carbon has 4 bonds. This one also has 4 bonds, so 4 different atoms that's bonded to that carbon and it's bonded to those 3 hydrogens. That would be an example. Something that would not be an example would be this. 2 carbons, there's a double bond between them, and then it can only form 2 more bonds, so with 2 other hydrogens. So these are only bonded to 3 different atoms. 1, 2, 3. So this double bond here means that it's not an alkane. We have a word to describe these carbons. They are what we call saturated. This is a saturated compound. Saturated, this word means when you take out your clothes out of the washing machine, they are absolutely ringing with water. They are holding more water, so much water that they can't possibly hold anymore. If you pour more water on, it will just pour off. We say your clothes are saturated. It cannot hold any more water. A saturated solution, you might remember from junior cert, is a solution where we've added so much of the solute, like salt or copper sulfate, that we can't add anymore. It can't hold any more salt or solute. Well, saturated in this case means the carbons cannot hold any more atoms. They cannot hold because they're already bonded to 4. This one, on the other hand, this is not bonded to 4. This is only bonded to 3. So essentially what we could do is break this bond and make it look like this one, add on some more atoms. So this is the opposite of saturated. This is unsaturated. Unsaturated. Okay. So saturated hydrocarbons are ones that are bonded, chemically bonded to 4 different atoms, all single bonds. Okay. The names of the alkane, any family or member of the family of alkanes, all name ends in -ane. So something ane. And we're going to see how we make the start of the name later on, but they all end in ane. So the alkanes all end in ane. Alkane and ane. So they'll all be something ane. Now we will see how we get the start of these names later. The shape of the carbons, because they are bonded to 4 different atoms, we call this shape of molecule, or this shape of atom, this shape of bonding, we call this a tetrahedral shape. And we saw that in one of the previous videos. And a bond angle between these lines, the bond angle is 109.5 degrees. 109.5 degrees. They are all relatively unreactive. Relatively unreactive. They don't do that many reactions. And the reason for this is because they already have, all their bonds are full basically. They've already bonded to 4 different atoms. So to make these react, we would have to remove one of these atoms and then add in or replace one. So we'd have to replace one of them atoms, pull one off and stick another one on. With this one, for example, this belongs to a different homologous series, by the way. This one is not saturated. It has a bond that could be broken and add extra atoms in. This is easier to do. This would be more reactive than this one because it's got some spaces, if you like, to stick extra atoms on, if you think of it simply like that. So these are relatively unreactive, but they do combust. Now, combust means they will burn. So they are relatively unreactive, but they do react with oxygen in a process called combustion. So we get alkane plus oxygen O2, and we will always get as a product, anytime we burn an alkane, we will always get CO2, which is carbon dioxide, and this is a problem with burning these fuels, is carbon dioxide is produced, and we will always produce as a byproduct also water. Now, why do we do this then? Well, we've already seen crude oil is very, very useful. It makes all our fuels like petrol and diesel. So we burn them because when we burn them, we can release a lot of energy. So that is desirable. What is undesirable is the release of carbon dioxide. So these substances, the alkanes, are relatively unreactive, but they will react with oxygen in a combustion reaction. The last thing is they all have the same general formula. Well, we know a homologous series always has the same general formula. So the general formula for the alkanes, it's a way we can work out what the formula will be for any alkane. Looks like this: CnH2n plus 2, where N equals the number of carbons. Okay, so what I'm going to get you to do now is pause the video and and you can make some notes on what I've just done. It's a good way of organizing stuff on one page, so you can do that now for me, please. So pause the video and copy that stuff down. Excellent, and we should now only be watching the video again if you have taken that down. Okay, and we now need to figure out how do we name the alkanes. Okay, so we know that the name is going to end in the letters A and E. How do we work out what the first part of the name is? Well, to do this, we're going to have to learn to count in organic chemistry. Now, the beauty of this is you have to learn this method, and it works then for all our organic compounds, this method. We have to learn to count in chemistry. And when we're counting, what we're counting is the number of carbon atoms. Okay, the number of carbon atoms will give us our prefix. Our prefix, pre means at this or before, so it gives us the bit that we say before the word, the part ane. So our prefix. Okay, now obviously our first one is going to start with 1 carbon. So if we have a 1 carbon alkane or any substance, 1 carbon, we use the prefix meth, M-E-T-H, meth. Okay, if we have 2 carbons, we use the prefix eth, E-T-H, sorry, spell it correctly, E-T-H, eth. So again, if this was an alkane, these would be methane with 1 carbon. And if there was 2 carbons, ethane. Okay, now what I'm going to do is I'm going to stop there, and I'm going to cover over these 2 like that. And I'm going to get you to start copying out that table. Okay, so you see the rough table I have drawn there. So you need to know number of carbons and the prefix. I'll leave that on show for you. So I want to pause the video, copy these 2 things down now, and then try and do these 2, 1 carbon and 2 carbons and their names from memory. So pause the video and do that now. Okay, and you should only be listening if you've now tried to do that from memory. Don't worry if you got it wrong, we can fix it, okay? But try first from memory. Okay, I'm going to show it to you now, so you should only be looking if you've tried it. There it is. 1 carbon is meth, and 2 carbons is eth, or meth and eth. Doesn't really matter. Okay, I'm going to do a couple more, and then I'm going to stop, and we're going to do the same. 3 carbons, the prefix is what we say, we call it prop. P-R-O-P, prop. 4 carbons is bute, B-U-T. So those alkanes would be propane and butane. Propane and butane, okay? I'm going to cover them over, and you are going to try and do them from memory again. Pause the video and add in the 3rd carbon and the 4th carbon. Okay, you should only be watching the video if you have tried to do the 3rd carbon and 4th carbon from memory. So 3 carbons we call prop, and 4 carbons we call bute. Okay, so we're going to keep going. We're going to go up to 10. So we've got 5 carbons. 5 carbons, our prefix is pent, P-E-N-T, like a pentagon with 5 sides, P-E-N-T. 6 carbons, what's a shape with 6 sides? It's a hexagon. We use the prefix hex. So those 2 alkanes would be pentane and hexane. I'm going to do one more before I stop. 7 carbons, we use the prefix hept, H-E-P-T. Okay, I'm going to stop there, and you're going to pause the video and from memory try and do 5 carbons, 6 carbons, and 7 carbons and then prefixes, please. Again, now you should only be watching the video if you have tried to do them. The answers are here. 5 carbons, we start with the prefix pent, P-E-N-T. 6 carbons is hex, H-E-X. 7 carbons, hept, H-E-P-T. Okay, I'm going to have to make my table a bit bigger here because I need to go to 10. 8 carbons is next. 8 C's. Anyone, if you know an 8-sided shape, you will know what this will be called. It's OCT, oct, like an octagon. Anyone's into MMA, you will know that they fight in an octagon. 9 carbons is non, N-O-N, non. And 10 carbons, like a decade is 10 years, D-E-C. D-E-C is deck. Okay, so again, I'm going to cover them over and pause the video and try and finish the table. Okay, and the answers are 8 carbons is oct, 9 carbons is non, and 10 carbons is deck. Well done if you were able to do those from memory. This is as far as you will need to count. So happily, we don't need to go any further than 10. Okay, and in a minute, I am going to get you guys to try and name the first 10 alkanes. I'm going to do the first one for you. It's going to be the first 8 alkanes. I'm going to do the first one for you here. Okay, so 1 carbon alkane. Well, 1 carbon, I'm going to take the prefix meth, M-E-T-H, meth. Okay, and then all alkanes end with the same name, so it's going to be methane, or methane is going to be the name, methane. Okay, now I'm going to get you to do these in a minute, and I want you to do them without this table in front of you. So you need to cover that over or close that page when you're doing the practice. Okay, so here are the questions. Now I'm just going to get to do question 1. Just question 1. I have showed you how to do the first one already. So we're going to pause the video and attempt to name the next 7 alkanes. So pause the video now. Okay, and welcome back. You should only be watching the video if you have tried to do question 1. So let's quickly flick through the rest of them. The second alkane is called ethane, E-T-H-A-N-E. The third one is called propane, P-R-O-P-A-N-E. The fourth one is called butane, B-U-T-A-N-E. The fifth one is called pentane, P-E-N-T-A-N-E. The sixth one is hexane, H-E-X-A-N-E. The seventh one is heptane, H-E-P-T-A-N-E. And finally, we have the 8th one, which is octane, and it's O-C-T-A-N-E. So well done if you were able to answer all those correctly. Now, To do question 2, I'm going to have to help you a little bit. Okay, I'm going to do a couple for you here. It says in an alkane, every carbon must have 4 bonds. Each bond will either be a hydrogen or a carbon. I want to draw the first 8 alkanes. Now, when we're drawing alkanes in general, we're going to assume, unless we're told otherwise, that the carbons are in a straight chain, all connected in a straight chain. So I'm going to do 2 for you and show you how it works, and then I'm going to get you to do the next ones. Okay, so here is how we would do this. Okay, I'm just going to put up the big screen here for you for a second. Okay, all right, I'm hoping now that you can see the big screen. Okay, so we said that this is question 2, and we said the first hydrocarbon is called methane, M-E-T-H-A-N-E. Now, what does meth mean? Meth means 1 carbon. Now, you got the hint in the question here that if all carbons must be bonded to 4 different atoms, they will all form 4 bonds. Now, if there's only 1 carbon, then all the bonds here have to be connected to hydrogen atoms, like that. So they must all be hydrogens. So we've got 1 carbon bonded to 4 hydrogens. The bonus here, if you're able to write the formula, what we call the molecular formula of this. Pause the video and try and do that now. Excellent. If you wrote this, well done. 1 carbon, so C, H, and we use a subscript 4 to show that there are 4 hydrogens. Excellent. If you were able to do that, we have done formulas before, so I hope you were able to do that. I'm going to do the second one. Ethane. It's the second alkane. Eth, this means 2 carbons. We said the carbons are connected in a chain, so they have to be connected to each other. Now, after that, each carbon has to have 4 bonds. So this carbon already has 1 bond here, so it's going to have 1, 2, 3 more. And if they're not carbons, then they've got to be hydrogens. So there we go. Because these are hydrocarbons, hydrogen and carbon only. And then this substance, this carbon, is also bonded to 4 atoms. So we know that it's going to be all hydrogens attached. The formula for that, please pause the video, see if you can write that down. Okay, if you wrote this, well done. C, and there's 2 of them, 1, 2, C2, H6. All right, well done if you got that bit right. Okay, so I've showed you how to do the first 2. Pause the video and see if you can draw the next 6. Okay, and I'm just playing again on the 3rd one. Okay, so just wanted you to check that you got this bit right, because if you didn't get this bit right, then the rest are going to be wrong. I hope that you can see when you've got a carbon that's in the middle, that's not on the end. So both these carbons are on the end of a molecule. They're on the outside. Here's the first one that we have a carbon in the middle. Okay, we've got 2 end ones and we've got 1 in the middle. Now, because this one's in the middle, it is bonded to 2 carbon atoms. That means it's only got 2 more bonds to form. So it's only got 2 hydrogens on that one. So these 2 are connected to 3 hydrogens, but the middle carbons are only connected to 2. Formula here would be C3H8. Remember, we said that the general formula would be CnH2n plus 2. So you can see how this works, where n is the number of carbons. Well, if n here is equal to 3, C3, then H is going to be equal to 2 times 3 plus 2, which is C3H8. And that's a way we can quickly work out the formula of any alkane. All right. Okay, and that is what the completed exercise should look like. First one is methane, 1 carbon, ethane, 2 carbons, propane, 3 carbons in a chain, and then after that is where we left off. We've got 4 carbons in a chain, butane, with 10 hydrogens. We've got 5 carbons in a chain with 12 hydrogens is pentane, 6 carbons in a chain with 14 hydrogens is hexane, 7 carbons in the chain is heptane, and 8 carbons in the chain is octane. And I'm guessing that you guys get fed up of drawing all them hydrogen atoms. Yeah, that is what tends to happen. So you're going to see later on that we can have shorter ways of writing them and drawing those. Well, now I've got some more questions for you to practice. Some of these are revision questions, some stuff we did a long time ago. Question 2, for example, talks about properties of simple molecular substances. We have studied this before, but it is quite a while ago, so you might need to go back and remind yourself. Also, question 3 and also question 4 and 5 are calculation questions based around the mole and atoms. So again, it's a chance to refresh all of that for yourself. Okay, so pause the video and go and have a go at those questions, please. Okay, welcome back, and you should only be now looking and watching video if you have tried all the questions. So I am going to put up the answers now. Some of them I'm going to have to do live here on the board, and other ones I am going to have the answers here. Now, first of all, I'm going to do question 1. Draw a molecule of nonane which has 9 carbon atoms. So nonane with 9 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. It's a pain to draw that many. And that carbon will have 3. This carbon has 2. This carbon has 2. This carbon has 2. All the middle carbons, as you see, they all have 2 because they are bonded to 2 carbons each. Like that. And then they have an N carbon again, and you're seeing again, here we've got 3. This is called nonane. Pause the video and try and do the molecular formula. Okay. Welcome back. You should be watching. If you tried to do the molecular formula, it will be, remember, we're going to use the formula CnH2n plus 2. That's the general formula for alkanes. Well, Cn, N is 9 carbons, 9 carbons. H2n plus 2. Well, H2n, 2 9s is 18 plus 2 is 20. So it's going to be C9H20. Well done if you got that correct. Questions 2 and 3, I have answers for here. Explain what the properties of nonane would be. Well, it's a simple molecular substance. Simple molecular substances have low melting and boiling points, so they are usually liquids or gases at room temperature. So they're either gases or liquids or soft solids at room temperature. We don't have any hard solids, so they have low melting and boiling points. And they do not conduct electricity. Okay, why can they not conduct electricity is number 3. Electricity requires charged particles to flow. So if electricity is going to move in a wire, it requires charged particles to flow. Well, methane does not have any charged particles. Each molecule is separate from each other. Okay, and when the molecules move around, they are not charged, so they cannot carry electricity. So for charge to flow, you need ions, charged particles. So ionic substances, when they dissolve or melt, separate into ions, which is what carries electricity. But simple molecular substances don't do this. Again, why? Well, they are not charged particles. For questions 4, 5, and 6, I'm going to need to jump to the whiteboard. Okay, so we're going to do the next question now. We were asked how many moles is in 100 grams of methane. How many moles is in 100 grams of methane? Well, from our section on quantitative chemistry, we know that a mole, number of moles, will equal the mass divided by the formula mass. So we have a mass of our substance here. So in the question, we were told we have 100 grams of methane. So that is our mass. Our formula mass is what is the mass of a mole of methane. Methane is CH4. So how much would a mole of that weigh? Well, we know a mole of any substance is equal to its mass from the periodic table expressed in grams. Sorry, that's not very clear, CH4. So the first thing I need to find is what is the formula mass? What is the formula mass? Question mark. Formula mass, also sometimes called molar mass or MR, for this substance of CH4. Okay, well, we know that carbon is made of 1 carbon, so C, and 4 hydrogens. There's 4 here, means 4 of the thing just before it, or to the left of it, so 4 hydrogens. like that. Okay. So I need to find out what is the mass of this compound, or this molecule. Okay, so carbon, if I go to the periodic table, I find that its mass is 12. So carbon times 1 is equal to 12 times 1, which is 12. Hydrogen has a mass of 1 from the periodic table. So multiplied by 4, because there are 4 of them. So how do I get it? Well, there's my mass of 1, and I'm going to times it by 4. Gives me 4. So add them together. 16 grams in every mole. 16 grams in every mole, grams per mole. That would be the units of formula mass. The amount of grams if I had 1 mole, grams per 1 mole. Okay, now I want to know how many moles I have, because I don't have 1 mole. If I had 16 grams, I would have 1 mole. I have 100 grams. Okay, so 16 grams per mole. So I'm going to stick this back up into the formula. That's what we call substituting, is sticking a number in instead of a word. So we know our formula mass number now is 16. We know our mass of our substance is 100. So moles is going to be equal. So plug it in. We're going to get 100 grams divided by 16 grams per mole. The grams are going to cancel out, and you're going to be left with the units of moles. Okay, so 100 divided by 16, calculator. 100 divided by 16 equals 6.25. The answer is 6.25 moles. Okay, well done if you got that correct. Leading on to question 5 now. The question, just as a reminder, was how many atoms are present in 2 moles of methane? 2 moles of methane. Okay, now, how many atoms are present in 2 moles of methane? Well, we already know from previously, we had this map to help us remember these things. We had moles. We know that a mole can be changed to mass, like that. We can do this by multiplying by the MR. We can find from the mass to moles by dividing by the MR. To go from moles and find the number of particles, a mole of any substance will contain the same amount of particles. The number is 6.02 by 10 to the power of 23. A reminder, speak on 3 if you remember the name of what that number is. So on 3, 1, 2, 3. I'm hoping you said Avogadro's number. So 6.02 by 10 to the power of 23 is Avogadro's number. So any substance, if we have 1 mole of it, we would have 6.02 by 10 to the 23. So we take our mole. If we have a mole, we got to multiply it by this number to get the number of particles. If it was 1, then it would just be 1 times this, which would be equal to this, that many particles. Okay. Now, likewise, if we had the number of particles and want to find out how many moles were in it, we would need to divide by that number, 6.02 by 10 to the 23. But that's not what we're trying to do now. We want to know in 2 moles, how many atoms would I have? Well, first of all, in 2 moles, it's going to be this many particles. So 2 moles equals 2 by Avogadro's number, 6.02 by 10 to the 23. So let's find that first of all. 2 by 6.02 times 10 exponential to the power of, on this calculator, it's that one to the power of 23. It's 1.204 by 10 to the power of 24. So equals 1.204 times 10 to the 24. Now, well done if you got as far as there. If you think that that was the answer, unfortunately, that is not the final answer. I know this is a little bit confusing, But we know that the substance that we're talking about is methane. Methane, so we've got this many particles of methane. You're all right. Ooh. Sorry, what's up? Do you have a silver pump, Jesse? Sorry about that. Somebody came into the room. So back to it. We have 1.204 by 10 to the 24 particles of methane. Okay. Now, particles of methane. Well, first of all, let's think about methane. What type of particle is it? Well, we know the formula is CH4. So this is a substance that's got 1 carbon and 4 hydrogen atoms chemically bonded together. So what do we call a substance which is made of, or what do we call a particle or a substance which is made of more than 1 atom that is chemically bonded together? On 3, 1, 2, 3. Okay, this type of particle is called a molecule. So this is molecules of methane. Molecules of methane. Now, we were asked in the question, how many atoms are there in this much methane? So each molecule is made of how many atoms? 1 carbon and 4 hydrogens. Altogether, that is 5 particles. 5 atoms, sorry, 5 atoms. 5 atoms for every particle. So if I have this many molecules, if I had just, we'll go back, if I had 1 molecule, how many atoms do I have? So it's 1 times 5, I have 5 particles. If I had 3 atoms, pause the video and tell me how many atoms I had. If I had 3 molecules, sorry, if I had 3 molecules of methane, how many atoms do I have? Pause the video. I'm hoping that you said 15, because each molecule has 5 atoms. So 3 by 5 is 15. How many would I have if I had 100 molecules? How many atoms would I have? If I had 100 molecules of methane, how many atoms would I have? Pause the video. Okay, speaking your answer out now. I'm hoping that you said 500. If I had 100 molecules, I would have 500 atoms. Okay, so if I have this many molecules, I have this many times 5. Okay, so at the number of atoms is going to be equal to 1.204 times 10 to the 24, but I'm going to multiply that by 5. The answer you got before, it should be still on your calculator. Times it by 5. You get 6.02 by 10 to the 24. 6.02, which is actually a funny coincidence because that's the same as Avogadro's number, but it's by 10 to the 23. Our answer now is by 10 to the 24. Okay, so 6.02 by 10 to the 24, and we're talking about atoms. Okay, super, well done if you got that. That was quite tricky because it's been a long time since we saw that, so well done if you got that correct. And the last question tells you that ethane reacts with oxygen to form carbon dioxide and water. Construct and balance a symbol equation for this reaction. Okay, construct and balance a symbol equation for this reaction. Right, well, first of all, we need to write down our reactants. Our reactants in this reaction go on the left-hand side of an arrow. An arrow shows us a chemical reaction is happening. Our reactants go on the left-hand side. So what are our reactants? Well, we're mixing together ethane. So what's the formula for ethane? So if you weren't able to do this, do it as I go. I want you to stop and I want you to write down the formula for ethane here. Pause the video. Okay, and if you did that, well done. It's C2, and if it's 2 carbons, how many hydrogens is it? Well, it's CnH2n plus 2, remember? So it's 2 times 2 is 4 plus 2, so it's going to be H6, C2H6, and I'm reacting it with oxygen. The equation or the symbol or the chemical symbol for oxygen is O2. So C2H6 plus O2. If we form carbon dioxide, which has a chemical formula of CO2, plus our other substance we form is water, and our chemical formula for water is H2O. Okay, if you haven't done this already, I want you to pause the video and label above them which ones are the reactants and which ones are the products. Pause the video. Okay, well done. If you did it like this, these are reactants and these are products. Now, we know of a rule in chemistry. It's one of the most important rules in chemistry. It's what we call the law of conservation of mass. And that tells us that atoms in a reaction, atoms or mass, cannot be created or destroyed. We just break bonds apart and move the atoms around. We never create or destroy any. And that means that if we start with a certain amount of atoms, whatever, if we start with, say, for example, 6 hydrogen atoms, we have to finish with 6 hydrogen atoms. They cannot disappear, and we also cannot add more. Now, when we were doing balancing equations, I would have showed you a method called balancing boxes. Mr. Gaffey's balancing boxes. How does this work? Well, we're going to draw the number of atoms that we have. So we're going to draw, this is made of 2 carbon atoms like that, and 4 hydrogen atoms. Now, we are going to put a box around that. The box just means that we can't separate that substance. We can't lose those hydrogens from the carbons. The oxygen atom, the oxygen molecule is 2 O's combined like that, and we're going to box that. The carbon dioxide is 1 carbon and 2 oxygens like that, and we're going to box that. And the water, the H2O, is 2 hydrogens and 1 oxygen. And again, these are the balancing boxes. We cannot break open the box. So that means that if we want to change anything, we cannot take a hydrogen from this box, or an oxygen, sorry, from this box and put it somewhere else. Okay. If we want to create another carbon here, we have to create a whole box. Okay. Now, again, I'm hoping that makes sense if you've done this before. If you haven't, I'm going to explain it in a minute. Okay. Now, the next thing that we're going to do is we're going to count to find out what is missing. Okay, what is missing from the left and the right. Well, on the left here, if I look along the reactants, I will see that in the reactants, in total, I would have 2 carbons, and they are here. So carbon and carbon. There's no other carbon here. So 2 carbons. And on this side, if I look across the 2 products, I only see 1 carbon. Carbon, 2 oxygens, no other carbon. So I've got 2 carbons in the reactants, but only 1 carbon in the product. So that is a problem. So I need to make sure that my rule of the law of conservation of mass is not broken. Now I can't just say, oh, I've got a spare carbon there, now it's balanced. I can't do that, okay, because then I'm breaking it from the 2 oxygens. So if I am going to put a carbon, I have to make one of everything that's in the box. So I have to make another box, basically. Okay. I have to make the whole thing. So now my carbons are okay. I've got 2 carbons and I've got 2 carbons. Now let's check the hydrogens. Check the hydrogens. On the left, in the reactants, I've got 4 hydrogens. 1, 2, 3, 4. There's none here. 4 altogether. On the right, in the products, I've only got 2 hydrogens. Again, I can't just add 2 hydrogens by themselves here. That's not fair, because the hydrogens are connected with a water. This here, if I was to do this, this would not be the same substance as this. This would just be hydrogen. There is nowhere in the products where the hydrogen by itself is formed. It's water that's formed, so I have to keep it as water. What's in the box here is water, so I have to only form a water molecule. So H, O. Okay, so I've made a whole other box here. Okay, so now my hydrogen's okay, just double check. 1, 2, 3, 4, and 1, 2, 3, 4. Good. My carbons are okay, I've done that. Now my oxygens, I need to check. On the reactants, I've only got 2 oxygens at the moment. And in the products, I've got 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. So 6 on the product side, and I've only got 2 on the reactant side. So if I make another box of oxygen, now I've got 4. That's not enough. I need to get to 6. Hopefully you can see. I need to make another box here. That will get me to 6. Now, remember, each box represents a molecule or a ratio, if you like, a ratio of reactants. So underneath, I need to rewrite out this equation to show what I've done with the boxes. Well, here I still only have one box. I only have one of this thing. So this thing is going to say the same, C2H6 plus. Well, now I've made 3 of the boxes of oxygen. So this is going to be 3 O2s. To give me, I've made 2 boxes of CO2, so 2 CO2s. And I've made 2 boxes of water, 2, so plus 2 H2O. So I show by putting a large ratio number in front of each substance, how many boxes or how many molecules of each of the thing I've made and created. So now this is properly balanced. All the atoms that were there at the start are still there at the end. Nothing has been created or destroyed. So this obeys the law of conservation of mass, and it is correct. Well done if you got that right. Excellent. Right, the next part is going to be about how we can, the different ways we can write the formulas of substances, of alkanes, for example. We talked earlier about having to draw out all those lines and all the hydrogens. It gets a bit tedious after a while. So is there other ways of doing it? Well, the answer is yes. Well, up to this point in your studies, chemistry, you will have a formula would have meant really only one thing, and that is what we call the molecular formula. Molecular formulas. This is what you would have seen so far. Molecular formula is just one which tells you the type and number of the atoms in a compound. So example would be CO2. What does this tell you? This tells you you've got 1 carbon and 2 oxygens, 2 oxygens. Okay, another one, H2O, tells you you've got 2 hydrogens and 1 oxygen. I'm going to give you a more difficult one to do now, just to recap. Glucose, C6H12O6. How many does that have? Pause your video. Okay, hopefully we said 6 carbons, 12 hydrogens, and 6 oxygens. So that's what we know and understand by a formula so far. That's still relevant for organic chemistry, but there are other ways of doing it. So we're going to take an example now, and we're going to do it together. Okay, I'm going to do it for you first of all. All right, so we're going to look at the different ways we can represent organic compounds. And the first one is one that we are already familiar with. It's called the molecular formula. It's what we just did. So it's the standard formula for showing the elements present and the number of atoms of each element. Our example we're going to use in the video is butane, B-U-T-A-N-E, butane. Okay, and butane's chemical formula. Well, we can use our general formula. Alkanes are CnH2n plus 2. So butane, how many carbons does something with but have? Speak your answer to the video now. I'm hoping you said but means 4 carbons. So if we make carbon C equal to 4, if N is equal to 4, how many hydrogens do I have? Speak your answer now. I'm hoping that you said H10, because it's 2 times 4, which is 8 plus 2, is 10, C4H10. That's a molecular formula. There's nothing new there. It's pretty easy. Another way we can express formulas is in a formula showing the elements present and in the lowest possible ratio. The lowest possible ratio. So in this case, that is going to be your general formula. It's going to be your CnH2n plus 2. That's the simplest ratio you can have, or Yeah, that's going to be the simplest ratio you can have for these types of formulas, these types of compounds. Okay, the structural formula shows in minimum detail the arrangement of atoms or groups of atoms in a molecule of a compound. Okay, now this basically breaks up the C4H10 to show us the different parts of the molecule. So C4H10 tells us how many carbons there are and how many hydrogens there are, but nothing about how they're arranged. Okay, now to be able to do this, you really need to have really need to have done the displayed formula first. So I'm going to skip and do the displayed formula first before I do the structural formula. Okay, you'll just see why it's easier in a minute. So I'm going to skip and do the displayed formula. This shows every atom and every bond in one molecule of a compound. So this is what we did earlier when we drew the alkanes earlier. We were drawing the displayed formula. So for butane, I've got 4 carbons in a chain like this. 1, 2, 3, 4. So this is what a displayed formula is. It displays for us where the carbons and hydrogens are. I then draw my 3 hydrogens in like this. This one will have 2 hydrogens. This one will have 2 hydrogens. And this one has 3 hydrogens. So that's a full displayed formula. And generally, if you're asked to draw a molecule, that's what they're talking about, the displayed formula. Now, why is it easier for us to now do the structural formula? Well, the structural formula takes sections. So for example, it takes this section of the molecule and tells us what's there. So for example, this part here would be CH3. CH3. So that tells us a little bit more about, instead of just C4H10, it tells us a little bit more information. We have a carbon that's bonded to 3 hydrogens. Then we take this bit. So the carbon that's bonded to 3 hydrogens is followed by a carbon bonded to 2 hydrogens. So CH3, CH2. We then take another section, CH2 again. Now stop the video and see, can you write out the next bit? Pause the video. Okay, you should be playing now if you've tried to do that. So hopefully you see, because this is a CH2 group, we're going to have CH2 again. So CH3, CH2, CH2, and what will the last bit be? Again, pause the video and try and finish off the structural formula for butane. Okay, hopefully you now saw that the last section is going to be this little piece here. It's going to be CH3. So CH3, CH2, CH2, CH3. This is what we call a structural formula, and it shows us in minimal detail the arrangement of the atoms, or groups of atoms. Okay, so this is not as detailed as this one. This one draws it out and makes it visible for us. Okay, the last one's my favorite because it lets us shorten it, but we have to be careful about overusing it. If we need to see the detail of the molecule, then it's important that we don't use the skeletal formula, but it can be handy in certain situations, especially when we get good at this and we're very familiar with it. We can use this. So what is a skeletal formula? It shows only the bonds of the carbon skeleton and any functional groups. Carbon atoms are not shown, nor are hydrogen atoms that are bonded to the carbon. So we don't have to draw any of the carbons. Now, in general, we would show the carbons like this. So we would start here and we would draw a line, and that line represents a carbon to a carbon. We would then draw another line going the other way. That would be carbon, carbon, carbon. So each end of a line is a carbon, and that would be the 4th carbon. So 1 carbon, 2 carbons, 3 carbons, 4 carbons. A chain of carbons in a skeletal formula, we would draw in like a zigzag line. Now this shows us, each point on the line shows us a carbon. So there's 1, 2, 3, 4. Now, there are no other functional groups in here, like there is no double bonds, or there's no other atoms like an O or a Cl or anything else stuck on here, so we don't need to show any of the hydrogens. We would assume, if you looked at this, you need to know then that there's always hydrogens attached to the carbons. This is a carbon at the end, so it's the exact same as this. There would be 3 carbons there. You need to know that because it's at the end. It's got 3 hydrogens attached, 3 hydrogens. This is a carbon in the middle which is going to be attached to 2 hydrogens. And the reason for that is look at the 2 bonds coming out of it. It's already bonded to 2 carbons. It can only make 2 hydrogens after that. There's another carbon bonded with 2 hydrogens, and there's a carbon on the end which is bonded with 3 hydrogens. Okay, so well done. That was hopefully what I'm going to get you to do actually is I'm going to get you to pause the video and copy this down, the 5 different ways of representing a different formulas for organic compounds. So molecular formula, which is C4H10, empirical formula, which is the general formula, CnH2n plus 2. The structural formula shows us minimal detail, CH3, CH2, CH2, CH3. The displayed formula, which is the full drawn out version, which we should be good at already. And then the skeletal formula, which is new for us, a zigzag line to show the carbons. Each end of a line or each point of a line is a carbon, and we don't need to draw any hydrogens. Okay, so pause the video and copy that down. Okay. Okay, and last set of practice questions. Last set of practice questions for today. A chance to round up all that you've learned today. So I want you to pause the video and try and complete the questions for me, please. Okay, well done. You should only be playing this now if you have attempted all them questions. And this is really important to round up what we've learned today. Okay, so first of all, how many valence electrons does carbon have? Carbon always has 4 valence electrons, 4 valence electrons. What is the general formula for an alkane? It's CnH2n plus 2. Any alkane, you can find out its formula by using the general formula. Just stick in the number, instead of n, stick in the number of carbons, and that'll work out the formula for you. How many carbons are in pentane? Well, pent means 5, so there are 5 carbons. How many hydrogens are in pentane? Well, use the formula, CnH2n plus 2. Will give you the answer of 12. There are 12 hydrogens in pentane. What is the molecular formula for pentane? It's C5H12. Draw the structural, displayed, and skeletal formula for pentane. Okay, so I'm gonna have to go to the big screen for that. So share. And pentane it was, so just need to double check. Okay, so you had to draw the structurals, displayed, and skeletal for pentane. Pentane has a molecular formula of C5H12. It's important to know that. Again, I would advise that it's a good idea to draw the full displayed formula before trying to do the structural formula. It's just easier to do it like that. So pentane has 5 carbons in a chain, 1, 2, 3, 4, 5. And we stick our hydrogens on, 3 at the ends, 2 in the middle ones. Like that. It's very tedious after a while, I granted, but it's an important skill. Okay, so this is pentane. Okay, right. So that is the displayed formula. Displayed formula. Now, the other one was structural formula. So we're going to take the sections, break it down, and hopefully you have done it like this. CH3, and this is this bit. Next bit, CH2. Next bit, CH2. Next bit, CH2. And finally, CH3. And again, hopefully you can see that this is only different from butane by a CH2 unit. And that's something we learned already, that in a homologous series, each member only differs by a CH2 unit. So this is the structural formula. And then my favorite, the skeletal formula is 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons. 1, 2, 3, 4, 5 carbons. This is the skeletal. Okay, now back to the questions. How many atoms are all the carbon atoms bonded to in pentane? They are all bonded to 4 different atoms. Every one of these is bonded to 4 atoms. Pentane is a saturated molecule. What does this mean? Saturated means that all the carbons are singly bonded to 4 other atoms. So just like this, just like pentane and all the alkanes, all the carbons have 4 bonds to 4 different atoms. Okay, well done. That was quite a long video, but again, we covered a lot of stuff. Well done if you got the practice questions correct. If you didn't, if there's any bit you didn't understand or you're not sure about the questions, go back and watch the video and check the explanation again, and then try the questions again. Okay, I hope you enjoyed. I'll see you in the next one.